reasoning that you did on that 2-card handout activity is called indirect reasoning. Why do you think it's called indirect reasoning versus direct reasoning? Yeah, you're not getting direct information. It's not telling you this person had a 10 of clubs. That's direct, right? Direct. I just told you what it was. Indirect, I said this person did not have this or this. Therefore, you had to say, okay, they had to have this. Right? That's indirect. Okay. So just for fun, just to get started today for this critical thinking riddle, we're going to read this riddle and try this out loud. Or try this, see if anybody gets it. Do you think they got it? I heard you got it. Keaton, what are you? It's his mother. Yes, that's why. So very good. We're actually going to skip that for right now. Sorry. Okay. So in this section, it's called indirect proof. Okay. Another word for an indirect proof. This is the only vocab you need to know from this section. Okay. It's what an indirect proof is, which is also called a proof by contradiction. These are the same thing. Okay. It's a type of proof that begins by assuming the denial of what is to be proved, and then deducing a contradiction from this assumption. Okay. Sounds like a long definition. It's really not too terrible. So what we're doing in these proofs is we're starting every proof after we get our given and what is to be proved. We're starting every proof by denying what is to be proved. And we're going to come to examples of that in just a second. And then once we do that, we're going to see if we deny that this is true, or what we're going to be proved, what to be proved is false, then we're going to get to some contradiction, something that doesn't make sense. Okay, this is called a proof by contradiction, which is also an indirect proof, which is this chapter. We're going to do them both indirect proofs with algebra, indirect proofs with geometry. What you did last class when I wasn't here was indirect reasoning. Okay, you got reasons for something indirectly. You had to find other information, other ways to get it. Okay. So how to write an indirect proof. Now you don't necessarily need to write each of these steps down because we're going to do a lot of practice with it. Okay. But we always start in an indirect proof by assuming the conclusion, or assuming what to be true, or what is to be proved is false. Every single one. If this is proved by contradiction or using an indirect proof, we always start by assuming the conclusion is false. And then we're going to show that this assumption leads to some contradiction of the hypothesis. The hypothesis is our given information. Okay? Or some other fact such as a definition, theorem, postulate, or corollary. Okay? That we get something that doesn't make any sense when we assume this. So then we point out that because we got something that's a false conclusion, it leads to an incorrect statement. The original conclusion is true. Does that make sense? So we're going to prove, instead of saying, okay, if this is true, this is what happens, we're going to say, all right, if this is true, we're going to assume the opposite. We're going to assume it's false, and then show that that's not true. Therefore, the original one had to be true. Okay. So these are going to be our steps in writing an indirect proof. So first I want to start out with just stating the assumptions you would make to start this indirect proof. Okay? If I gave you the statement EF is not a perpendicular bisector, the assumption we would make to start this indirect proof, we would assume this is false. Therefore we would say that EF is a perpendicular bisector. That makes sense, right? Okay? If I gave you this is what you're to prove you have no figure right now, you have nothing else. But if I told you to prove that EF is not a perpendicular bisector, we would start our proof by saying EF is a perpendicular bisector. Okay? We assume the opposite of what is to be proved. Okay? There will be quiz or test questions that just say this: state the assumption you would make given this information to start an indirect proof. You assume the opposite. Okay? So same thing, if I told you state the assumption you would make to start an indirect proof for 3x equals 4y plus 1, what would be the, how would we assume this is false? Yeah. Right, exactly. We'd say 3x does not equal 4y plus 1, right? Okay, we assume it to be false. If it says it's equal to, we're going to start our proof by saying it's not equal to. Okay. Then we're going to see how to apply this in a proof in just a second. Okay. So now we given all the information here. State the assumption you would make to start an indirect proof for the statement B is the midpoint of LH, and LH is 26. Therefore, BH is congruent to LB. Okay. So our given information, let's highlight what's given. Remember, given is our if part. So if BF is the midpoint of LH and LH is 26. That's given to us. So if we were to write our given, that's what we were given. What we're trying to prove is that BH is congruent to LB. Okay, that's our then part. That's what we're trying to prove. So we're going to negate this conclusion. We're going to start it. We would start our proof then by saying BH is not congruent to LB. We only negate what's to be proved, or the hypothesis. Okay? The orange parts are given. The yellow part is our conclusion, or what is to be proved. So we would start by saying, instead of BH is congruent to LB, we would start off by saying BH is not congruent to LB. Now, these proofs themselves, we're going to get actually how to use it in a proof. Right now, I just want to get down the assumptions. Okay, that instead of trying to prove this, we're going to start with it's not congruent. So looking at this one, state the assumption you would make to write indirect proof that AB is not an altitude. If we're trying to prove AB is not an altitude, our assumption for an indirect proof would be that AB is an altitude. Right? Okay, just negating our conclusion. State the assumption you would make to start this indirect proof. A is equal to 1/2 B minus 4. Therefore, we would start by saying, AB or A is not equal to 1/2 B minus 4. Okay. Last one here, I think. If LH is an angle bisector of MLP and MLH, or then MLH is congruent to PLH. Which of these negates what is trying to be proved? It's C, right? Because this is what we're trying to prove. We're trying to prove MLH is congruent to PLH. So our assumption would be MLH is not congruent to PLH. This is our given. Okay? We're given that LH is an angle bisector. We're starting by negating what is to be proved. Yeah, question?
Would you not add like the LH is not a bisector?
Right. Not an indirect proof. You only negate what is to be proved. Yeah. Good question. Or we only assume what is to be proved is false. Yeah. So now let's write an indirect proof. So this might be a good one to write down. Okay. So we're given that 1 divided by 2y plus 4 is equal to 20. Okay. So just like other proofs, let's just make this a 2-column one. Okay. What our given is 1 divided by 2y plus 4 equals 20. It's the only piece of given we have. What we're trying to prove, so this is an algebraic proof, right? What we're trying to prove is that y does not equal -2. Okay. So we want to assume the opposite of what is to be proved. So we're going to assume that what? Y is equal to 2. Because it said prove y is not equal to 2, so let's assume that y equals 2. Okay. So, oh, sorry, that's a -2. Thank you. Assume y equals -2. Instead of not equal to -2, we're going to say it equals -2. So, let's solve this proof assuming that y is equal to -2. So, we're going to start by putting that in place of y. What's my reasoning for being able to do that? What do? I just substituted, right? Substitution. Okay. Next, we're going to just multiply. All we did was simplify here. I wouldn't call this the multiplication property because the multiplication property of equality says if you multiply one thing to one side of the equal sign, you have to multiply it to the other. All we did was simplify, but simplify is not a reason. What's the reason we usually write instead of simplify? We would call it substitution again, right? Because we substituted in -4 for 2 times -2. Okay. So same thing. And you can abbreviate, just make sure you abbreviate long enough to know it's not subtraction. Okay. So again, then here we get this. Okay. So I substituted in 0 for negative 4 plus 4, so I substituted again. But why is this a major contradiction, or why is this not true? Right, we can't divide by 0, ever. Doesn't work, okay? Invalid. Your calculator says invalid or error or whatever. So this is not true. So since we arrived at our contradiction, we know that assuming that y is equal to negative 2 is false. Therefore, we've proved that y does not equal negative 2. So we could say the two-column proof, a lot of times we write it in a paragraph proof here, but if we wrote it in two-column, we would then say y equals, therefore y does not equal negative 2, and we could say proof by contradiction here. Contradiction, I ran out of room there, but we get the point. Okay. Yeah, that says contradiction. So, because this is a contradiction, this is not true. Okay. Therefore, what we assumed is false. Our assumption is false, therefore y does not equal negative 2 by contradiction. So that's how we use that in a proof. Any questions with that? Does that kind of make sense? We assumed the opposite, we arrived at something that wasn't true, therefore since we assumed the opposite, the original must be true. What if we assume the opposite and it does come out true? You can't prove it by using indirect proof then. Okay. Therefore the assumption must be false, which means y does not equal negative 2. So let's look at this one. Algebraic proof still. Write an indirect proof. 1 divided by 2a plus 6 is less than or equal to 12. I want you to prove that a does not equal negative 3. So if you don't want to do a two-column, you can just write it out like they did in the steps here. They said, okay, we're going to assume this, then we're going to solve it, and then this led to a contradiction. So our assumption is false, therefore what we are trying to prove is true. So given this one, let's say we'll set this one up that way. Our first step, okay, since it gives us our given and prove here, is we're going to assume what?
That y equals 3.
Right, that a equals negative 3. Right. So we're going to assume a equals negative 3. So then we're going to solve it. Okay. One divided by 2 times negative 3 plus 6 is less than or equal to 12. Okay. By substitution, 1 divided by negative 6 plus 6 less than or equal to 12. By substitution, 1 divided by 0 less than or equal to 12. By substitution. Contradiction. Again, we have a divide by 0 error, right? This doesn't work. Okay? So we can write, oftentimes like in the book, it'll say our assumption led to a contradiction. Therefore, a does not equal negative 3. We proved it by contradicting once we assumed our assumption is false. Yes? Question? Okay, go ahead, yeah. Logan, yeah.
So could you just write solve updated?
In that step, with the algebraic ones, yes. You do need to have the work of how to solve it. Like if you just say solve and then it's contradiction, I didn't see any of this work. If you just solved this and didn't write substitution each time, yes, that's fine. Okay. The reason I wrote substitution each time right now is to introduce it. You do need to actually solve it though, if that answers your question. Okay. In the algebraic ones, you do need to actually solve it. If you don't put substitution every time, that's okay. Okay. But you have to show how you got to that contradiction. Now, so in an algebraic proof, it's really easy to get a contradiction. Oftentimes, it'll be divide by 0. And that's a contradiction. That's an error. That doesn't work. Okay. Questions there? All right. Let's look at one more algebraic. We're going to correct the order here. You don't need to write this one down necessarily. It's kind of long. It says this guy bought 4 new sweaters for under $135. Tax was $7. But the sweater costs varied. Show at least one of the sweaters was less than $32. So what we're given is that he spent less than $135. And we're trying to prove at least one of the sweaters, we'll call it X, was less than $32. Okay? So if we bought 4 times X, 4 times each of the sweaters plus our $7 tax, should be less than $135. We want to prove X is less than $32. Okay? So our given is this, the if part. Our conclusion is this, the then part. So we're going to look at the order for this indirect proof and which is the correct order. So this A, B, C, this is not necessarily the correct order that it needs to be in. Okay. So which of these, A, B, or C, would start our indirect proof here? I agree. Part B should be first because we always start by assuming what we're trying to prove to be false. So instead of assuming that it's less than, we're going to assume that it's greater than or equal to. Now notice we put the or equal to in there. That's because our original, what we're trying to prove, was just less than. Therefore, we're going to contradict it, or we're going to negate that and say it's greater than or equal to. Okay. Which part would be next in this indirect proof? Yes, A would be next. Because we would say if X is greater than or equal to 32, then if we plugged in the minimum number here, 32, we would get 4 times 32 plus 7, which is $135. But that's a contradiction because it said he spent less than $135. And now we have it equal to. Therefore, our assumption led to a contradiction. So our assumption is false. Therefore, the opposite of the assumption, or what we were trying to prove earlier, must be true, and that one of the sweaters has to be less than $32. So a different type of contradiction here in that it was less than $135. We assumed the opposite, and we got to equal $135. Therefore, there's our contradiction. So now let's look at it from a geometry standpoint, an indirect proof. Okay. We're given triangle JKL, side lengths 5, 7, and 8. I want to prove angle K is less than angle L. Okay. Yeah, this would probably be a good one. Okay. So, it gave me my given and my what's to prove. So we're going to assume, we're going to start, since it's an indirect proof, with what assumption here? Yeah.
Angle K is not equal to angle L.
Very good. Not equal, but we're going to then make it, if it's not less than, then it's going to be greater than. Right. So instead of saying not less than, we'll say greater than. Okay. So measure of angle K is greater than or equal to the measure of angle L. Okay. So we're going to assume angle K, because that's the opposite of what we're trying to prove, right? So now we need to use this assumption to arrive at some contradiction. So let's look, angle K is here and it's opposite angle 7, right? And angle L is here and it's opposite side 8. So remember those theorems we did a couple classes ago? They said if an angle is opposite a larger side in a triangle, it's a larger angle. Anybody remember what that's called? Anybody got their postulate sheet out? In this case, we're looking at 5/9 because it says if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So we can say next, by theorem 5.9, the measure of angle L is greater than the measure of angle K. And if we wanted to be really specific here, we could say because 8 is greater than 7, right? But that's what 5.9 says. You don't really have to have that part, because 5.9 says if the side opposite is larger than the side opposite, the angle is opposite. Yes, question? Yes, because I got to account for the possibility that it could be or equal to. Just since this is strictly less than, I have to account for the or equal to somewhere in there.
So if it's or equal to,
Then we just would have put, right. We've got to account for or equal to somewhere. So now, this is my contradiction though, right? Because I assumed this, and I just proved this. So, therefore, there's a bunch of different ways you can word this, but this contradicts our assumption. So the measure of angle K must be less than the measure of angle L. We contradicted our assumption. We used our assumption. We arrived at something that was false because K was not greater than or equal to L. Therefore, what we were originally trying to prove is true. So this is measure of angle K greater than the measure of angle L, which is what we're trying to prove. Questions there? Last geometry we want to look at right here, very similar to the one we did previously. I just want to give you a different way to view it, or how you can prove it. So it says, given this triangle ABC, side lengths are shown. Prove that angle C is greater than angle A. Okay. Prove that angle C is greater than angle A. Now, if it didn't ask you to prove this by indirect proof, it would be very quick. This is very quick also. But you could just say, I know C is greater than angle A because of that theorem that says if the side opposite the angle is larger than the side opposite the angle in a triangle, then that's larger. We would say by 5 point, whatever that theorem was. Okay? But let's say we're going to prove it indirectly. So we're going to assume then the opposite. We're going to assume that C is less than or equal to A. Again, we included the equal to because we got to account for that possibility, since this didn't. So if we assume that C is less than or equal to A, this is a contradiction. Okay? Or, which part comes next? B or C, sorry. Because this is correcting the order. Which part would come next after A? A is the first part. It would be C, right? By the angle side relationships. Okay, this is a theorem we had. Okay. We know AB is less than or equal to BC. Okay. By substitution, 12 less than or equal to 10, this is false. Right? Because if this was true, this would have to be true. There's our contradiction. This is a false statement. Therefore, since our assumption is false or it leads to contradiction, since our assumption led to a contradiction, it's false and C must be greater than it. Okay. This is exactly like what we did before. We just called the theorem number here. Okay. And went from there. So that's proving indirectly. Okay. So it would go A, C, B in this case. Any questions there?